few times. Okay, the origins of the drag race date back, in my case, to the school's F1 event, and it was always the most popular event. You can see there that the track was raised. Wouldn't even think about that these days, but it was raised, and people surrounded it, so it was pretty good. They were pretty good at catching the mice when they fell off, which they inevitably did. In those days, it was at Manchester Metropolitan University, and it experimented with various designs, and it turned out that almost every design we ever tried did too much steering. So I had a look at putting two cut down Scalextric chassis back to back, so that it would generally run straight, and then finding a way of steering between the joints, so putting some sort of hinge in here so that you could steer just by changing the geometry of the chassis. That seemed to work, and Duncan designed a controller for me which had incredible traction control, speed control, braking. It read the distance on the odometry. All I had to do was, using a pickaxe microcontroller, as I did in those days, was to control the steering, which was bang bang steering in those days. And schools were just getting into kits, CAD and laser cutters, so the first proper chassis is the actual chassis that I use now, made of 2mm acrylic, light and strong, and I only needed to minorly change it for the current incarnation of missile. So there's the current version. It's got 4 sensors at the front, it's got brake lights at the back, very small circuit board, electronic speed control, and a servo steering. Underneath it looks like this. So you've got a hinge, so this top bit here just pivots by virtue of the servo there. Batteries just trapped underneath the circuit board. And there's the brake lights. I went overboard a bit, you might think, having 3 10mm brake lights, but when it's going quite fast, you need to see when the brakes are coming on, and that guarantees that you've got a half a chance of seeing it. And it's got a sensor at the back, similar to a line sensor, so that you can start it by just pulling away a piece of plastic. We did have originally some sort of micro switch starting, and very unreliable. This way it's touch free and the thing gets away pretty quickly. The design of the front, you've got, it's a good opportunity to show you that what I've got here is a Scalextric motor and a set of gears which is about 4:1, and Scalextric tyres. In this case, they are the thing for the job, you know. Something soft and with some width is good. So the dimensions, I designed it to be roughly at the limit of the length. The width was limited by how big a piece of steel I had for the axles. So it's 130 wide, the wheelbase is 180, the track distance is 115, tyres 22mm, width of tyre 12mm. Then I got my parts from eBay, and Scalextric do a set of spares, and you buy the gears in sets of 5, and also in the pinion, and also the gears, and you can get spur gears and crown gears, and you can get motors in different speeds. The one I use are 30,000 RPM, but obviously they don't go at that speed when it's running. So I use an electronic speed control from radio control aeroplanes, etc., and a 9-gram servo. The only capability of the ESC is that it should be able to go in reverse. It doesn't matter if it hasn't got a brake. The braking on missile is done by slamming it into reverse. And the servo should have metal gears, because you will crash and you will strip the gears. So, giving you an idea of how much everything cost, 2 motors, £10 each, so £20 for the motors, tyres you need 2 sets because the front wheels of Scalextric's cars are thinner than the rear, and you really want the wide ones front and rear. So 2 sets for £10. Pinion gears, very cheap, 2 sets only cost you £12, but the spur gears are expensive, £36 for 2 sets. If you could buy them individually, it wouldn't be so bad. I'll use the standard photo interrupters for detecting the line, and for the photo interrupter for the odometry, and use a PIC microcontroller, same one as I ever did, £3.40. Red LEDs, £2, 2 axles, 50p. I haven't costed in the smaller items. And the performance of missile largely depends on the reactions of the operator. You can have the fastest mouse in the world, but if you're not quick off the mark in starting, it just adds to the time of the mouse. And it's usually said that the best you can do in reaction time is 0.15 of a second, but that represents 7.5% of a 2-second run. And it depends on your age and your muscle memory. The more you practice, the better you get. And unfortunately, there's nothing you can do about slowing down your reactions due to age.
But in the spring competition, in the final, when I was next to you, you had the reactions of a 10-year.
Yeah.
I could hear your missile zapping down before I even seen it turn. And I thought, oh, it's the false run, and no, you hadn't.
I knew you were fast, I anticipated.
You successfully anticipated.
You get more experience, you get better at anticipating.
The timing gear had a variable final delay.
Yeah, I was just going to say, Dave had told us before the final that he didn't have a delay that was random. He told us he had a fixed delay, so I took a chance. Admittedly, your mouse was under 2 seconds, wasn't it?
1.8.
Yeah. So it would have been a lot closer, I assure you. So it depends on the eye-to-hand reaction time and etc. But when you get to my age, kneeling and getting up tells you that it's really a young person's game. I struggle now to get down and get back up again. The track surface has got a deal of influence on the performance. You can perform unreliable if it's made of badly jointed sections. The IET track is like a switchback. If they're not flat, the individual sections, it's blackboard painted MDF. That's about the worst surface, even if it's flat. If it's dusty or has been walked on, that can help. And if the white line is crooked, that doesn't help either. So there are a couple of improvements that I've thought of over the years. It's definitely the way to go to have four-wheel drive, but the servo steering is a bit overkill. It probably needs to be designed out. We saw a four-wheel drive mouse that had the conventional two wheels on each side driven with the same motor, and that was very fast. It had no problem holding the line, and it's probably the way to go in future. And it might also be worth investigating a mouse with a motor on each wheel. Obviously, people will try that at some point. I haven't tried it yet. Any questions? No? We'll get back on schedule.